Measuring temperature by sense of touch. Place 3 bowls in a row. The first containing ice-cold water, the second lukewarm water, and the third hot water. Put your left hand in cold water and your right hand in hot water. After a few seconds, plunge both your hands simultaneously into the bowl containing lukewarm water. The water will feel cold to your right hand and at the same time hot to your left hand. 9. Conduction of heat in metals. Take an iron rod, hold one end of the rod and put the other end in the flame of a candle. After some time, you will notice that the part of the rod you are holding becomes hotter. Though this part has not been directly heated, it is because the candle flame was hotter and its heat flowed or got transferred to the rod by conduction. Conduction of heat in a metal rod. Fix a number of drawing pins with wax on a metal rod at a regular distance from one another. Fix the metal rod to a clamp stand. Heat the rod at one end with a candle. What do you observe? As the rod is heated, you will find that the drawing pins drop one by one, starting from the hot end. The pin marked 1 drops first, then pin 2, and so on. The drawing pins drop because the wax melts by the heat which travels from the hot end of the rod to the cold end by conduction. 7. Good and bad conductors of heat. Take 4 rods made of iron, copper, aluminium and glass of equal length and thickness. Now insert equal length of each of these rods in a vessel. Coat the portion of the rod outside the turrow with wax. Pour hot water in the vessel. As heat travels through the rod, wax coating on the rod starts melting. You will see that wax melts to different extent in different rods. What can you conclude from this experiment? This experiment shows that different substances conduct heat differently. This also shows that substances like iron, copper and aluminium are good conductors of heat, whereas glass is a bad conductor of heat. Water is a bad conductor of heat. Take some water in a test tube. Wrap a piece of wax in a wire gauge and place it in the test tube so that it sinks to the bottom of the tube. Now hold the test tube in an inclined position and start heating the water in the upper part of the tube. You will find that the wax does not melt even when the upper part of the water starts boiling. What do you infer from this experiment? This experiment shows that water and other liquids is a bad conductor of heat. Air is a bad conductor of heat. Hold the test tube in an inclined position. Heat the lower end of the test tube. Now insert a finger into the mouth of the test tube. You will feel only some heat at the upper end, though the lower end is too hot to touch and may burn your finger. This experiment shows that air is a bad conductor of heat. Heating a liquid by convection. Take a beaker and half fill it with water. Drop some crystals of potassium permanganate in it. Now heat the beaker and watch the movement of colored solution. In this experiment, the liquid at the bottom of the flask gets heated first. This warm liquid, being lighter than the surrounding cool liquid, rises up. The colder liquid moves down, gets heated and in turn rises again. The heat is transferred from the hot water at the bottom of the beaker to the cooler water at the top by the actual movement of the water itself. Hot air rises upwards. Take a glass box with 2 holes, one at the side and the other at the top. The hole at the top should be fitted with a glass chimney. Place a burning candle in the box under the chimney. Bring a burning drinking straw near the hole at the side. You will see smoke entering the box through this hole and rising through the chimney. If you place your hand above the chimney, you can feel the hot air rising upwards. The air above the candle flame becomes hot and expands. This hot air becomes less dense, rises vertically upwards and escape out of the chimney. Cooler air is drawn into the box from the hole at the side, which replaces the escaped hot air. The movement of hot and cold air set up a convection current. The smoke produced by the burning straw held near the hole at the side makes the convection current visible. Radiation in black bodies. Take two identical tin cans. Paint one of them black and the other white. Fill both the tins with equal quantity of boiling water. Note the temperature in each can after every 5 minutes. You will find that the temperature of water in the black can falls more quickly than in the white can. Absorption in black bodies. Take two identical tin cans. The first one is colored black and other one white as in the previous experiment. Pour equal amount of water in each can. Place both the cans in the sun and note their temperature after every 5 minutes. You will notice that the temperature of water in the blackened can will rise faster than that in the white one. This proves that a black body is a good absorber of heat. The amount of heat absorbed by a body depends on the nature of the material of the body. Take 250 milliliter of water in a beaker and same quantity of refined oil in another similar beaker. Put a thermometer in each beaker to measure the temperature. Initially, the temperature of the water and refined oil will be the same. Heat both on the same heater and note the time taken by each to rise the temperature to 75 degrees Celsius. You will find that the time taken by water is different from that required by refined oil to warm through the same range of temperature. This experiment shows that the amount of heat absorbed by a body depends on the nature of the material of the body.